Hello everyone! During the 9th International Renewable and Sustainable Energy Conference, I will present my work entitled Electric Vehicle Progress and Challenges on the Road to Sustainable Transportation. This work is performed in energetic, mechanical and industrial systems research structure. To give more details, I have adopted the following plan. First of all, general introduction and aims, and then definitions and comparisons, electric vehicles integration challenges, technical and economic mutations, research questions. At the end, I will draw some conclusions and perspectives. As you know, human emissions of carbon dioxide and other greenhouse gases are a primary driver of climate change and present one of the world's most pressing challenges. Climate changes are irreversible, and the world cannot afford to gamble on this critical decision. To set the context, let's analyze the CO2 variation during the last 3 years. The main result is the decrease in global CO2 emissions in the first half of 2020 compared to the same period in 2019, and this corresponded to the lockdown situation in each country. By 2021, global CO2 emissions are expected to rebound with demand of coal, oil, and gas. Overall, emissions are recovering with the resumption of daily activities, especially transportation activities. In this context, one potential step to reduce emissions and mitigate climate change would be the widespread adoption of electric vehicles, which can be powered by electricity generated by sunlight, wind, and water. To better understand how electric vehicles contribute to environmental mitigation, we must know the main characteristics. We start with the definition and the technical aspects. So, an electric vehicle is propelled by one or more electric motors and powered by a battery or a fuel cell. The main advantages are reducing pollution, high efficiency, and uncomplicated maintenance. Taking into account the energy supplements and the propulsion systems, electric vehicles can be classified into 5 distinct types. Battery electric vehicles propelled by electric power and use large packs of batteries to give acceptable autonomy. Hybrid electric vehicles propelled by a conventional engine and electric engine. We distinguish the serial, parallel, and split modes. Plug-in hybrid electric vehicles that can store electricity from the grid to reduce their fuel consumption in regular driving conditions. Range-extended electric vehicles similar to battery electric vehicles, but they are provided with a supplementary combustion engine which charges the batteries, and fuel cell electric vehicles that are provided with an electric engine that uses a mix of compressed hydrogen and oxygen from the air. One of the top challenges of vehicle electrification is the limited range of lithium-ion batteries. Furthermore, the battery's design is limited by the size and the mass of the pack. Increased mass requires more energy for vehicle movement and negatively affects the vehicle's handling, acceleration, and braking. Charging infrastructures must be increased in the future, as well as faster charges to make electric vehicles extremely competitive with conventional. The biggest issue is the long-distance travel, where charging stations are not available. Also, the type of connectors used, which are different between American, Japanese, and European markets. Regulatory framework. In this side, the government must develop a national strategy for electric and plug-in hybrid vehicles deployment, also provide an energy transition law for a greener future. The reliability of powertrain components on the road is a key challenge for powertrain design engineers, as these components are vulnerable to environmental stresses such as temperature variation and mechanical shocks. The design of thermal management systems is vital in determining the efficient operation of e-powertrain components. Batteries are one of the most important components of electric vehicles, since they are one of the most costly components and affect directly performance. The improvements in terms of durability, charging densities, and the charge-discharge processes have caused the use of multiple resources in the development of new technologies that can surpass the current lithium-ion batteries. At present, Some of new technologies are lithium iron phosphate, lithium air, and lithium metal. About the market evolution, electric vehicle sales volume has experienced significant growth, especially in the last years. Moreover, many countries are preparing for the mobility transition and discouraging the use of fossil fuels. Finally, some interesting research areas related to the topic: understanding vehicle use profiles, electric vehicle benefits and the environmental impacts, development of new technologies able to surpass the current lithium-ion batteries, development of charging process and improving electrical infrastructures, exploiting renewable resources to electric vehicle charging, software systems for energy management in electric vehicles, design techniques and prime materials used in the manufacturing phase, development of new thermal management systems, and reduce the total energy consumption. So to summarize, this presentation discusses the variation of CO2 emissions during the pandemic and its impact on the environment. As a result, electric vehicles will be a necessary solution in the future. The major categories are discussed, as well as the most recent developments on some models. Moreover, energy recovery methods must be studied to recycle energy, which is important for improving the total energy efficiency of electric vehicles and maintaining safety in complex conditions. The future work will focus on motorized components by making a detailed comparison between the various types of electric motors to understand their benefits, limitations, and selection criteria. Finally, thank you for your attention.